The Concorde's final roar in 2003 seemed to slam the door on supersonic passenger travel, trading speed for efficiency and silence. Yet the hunger for faster flights never died. People still crave a world where a transatlantic trip takes hours, not half a day. Enter the XB-1, dubbed Baby Boom, a sleek testbed from Boom Supersonic that's paving the way for a new era of commercial flight. Promising Mach 2.2 speeds, sustainable fuels, and affordable tickets, it's not just reviving the Concorde's dream, it's aiming to outdo it. In this video, we're diving into the XB-1's tech, its path to the Overture airliner, and whether Boom can make supersonic travel mainstream by 2030. Buckle up, this is the future of flight. Supersonic travel is a beast. Breaking the sound barrier, as Chuck Yeager did in 1947 with the Bell X-1, isn't just about speed, it's a brutal fight against physics. Shock waves, searing heat, air resistance, and sonic booms that rattle windows for miles create engineering nightmares. But its $21,000 tickets, adjusted for inflation and deafening booms over land, made it a luxury, not a staple. The Soviet Tu-144 flopped, and economic, environmental, and political hurdles kept supersonic jets rare. Today, Boom Supersonic, a Denver startup founded in 2014, is rewriting the script with innovation and grit. Boom's journey started with the XB-1, a single-seat demonstrator nicknamed Baby Boom. At 68 feet long with a 21-foot wingspan, it's a fraction of the Concorde's 202-foot length and 84-foot span. Unlike the Concorde's drooping nose, which tilted for landing visibility, the XB-1 uses a glass cockpit and auxiliary cameras for taxiing, keeping the design light and simple. Its body blends carbon fiber, titanium, and A286 stainless steel to handle Mach 2.2's 307-degree Fahrenheit skin temperatures. The tail is 90% titanium, with high modulus carbon fiber for the wings and heat-resistant epoxy for the nose, thanks to Dutch firm 10Kate Advanced Composites. 3 General Electric J8515 turbojets, each pumping 4,300 pounds of thrust, power the XB-1 to Mach 2.2 with a 1,200-mile range, proven tech from the F-5 fighter and T-38 trainer. So, the XB-1's real mission, honestly, is to prove Boom's vision for the Overture, a 201-foot airliner with a 106-foot wingspan, set to carry between 64 and 80 passengers at Mach 1.7. 4 Symphony engines, developed with GE additive and Florida turbine technologies, deliver 35,000 pounds of thrust each, which enables a range of 4,250 miles. Unlike the Concorde's gas-guzzling afterburners, Symphony uses sustainable aviation fuel, cuts operating costs by 10%, and meets strict ICAO noise and FAA emission standards. Overture's range covers over 500 routes, slashing travel times, like Newark to London in 3.5 hours, or San Francisco to Tokyo in 6. But you know, trans-Pacific flights do need refueling, which is honestly a small price for such speed. Boom's approach really flips the aviation script. While giants like Boeing have leaned on their massive scale, Boom's startup agility, shaped through Y Combinator back in 2016, managed to draw in about $700 million from investors like Japan Airlines and United Airlines. By 2022, they had already racked up 146 pre-orders for the Overture. The Greensboro, North Carolina Superfactory is set to churn out 100 airliners each year, and it anchors their ambition to deliver somewhere between 1,000 and 2,000 planes by the 2030s. Even the U.S. military, working through Northrop Grumman, sees some real potential in Overture variants for rapid medical evacuations or surveillance missions, blending both commercial and defense roles. The XB-1's test flights are, well, really rewriting history. In March 2024, it flew from Mojave, California, and then in January 2025, it broke the sound barrier in the same corridor where Yeager made history. A second supersonic flight in February 2025 cemented its success before retirement, shifting focus to Overture. Boom's CEO Blake Scholl is targeting a 2026 prototype, a 2027 first flight, and passenger service by 2029 to 2030 after FAA certification. At $5,000 per ticket, yeah, that's steep, but honestly it's a steal compared to Concorde's $21,000. Overture aims to democratize supersonic travel. The challenges are honestly brutal. Supersonic flight demands real precision. At Mach 1.7, the Overture's skin reaches about 250 degrees Fahrenheit, which means it needs some pretty advanced composites and cooling systems. Sonic booms, are banned over land, so that limits routes to mostly transoceanic paths. Still, Boom is working on this quiet boom technology. Certification is a real gauntlet. FAA and ICAO rules demand nearly silent operations and zero-emission fuels. The Concorde, back in the day, burned about 25 tons of fuel per hour, so Overture's efficiency really hinges on Symphony's unproven design. Scaling up production to 100 planes a year, while keeping costs at $200 million per jet, rivaling next-gen fighters, is definitely a gamble. Yet Boom's early wins, like the XB-1's flights, show they're not bluffing. What sets Boom apart? Innovation and focus. The XB-1's lightweight design ditches complex mechanisms like the Concorde's nose, cutting weight and maintenance. Symphony's sustainable fuel compatibility aligns with global carbon goals, sidestepping the Concorde's environmental backlash. Partnerships with GE and Northrop Grumman bring expertise, while the Superfactory ensures scale. So, pre-orders from United and American Airlines really do signal a strong sense of market trust, even though there are some anonymous buyers out there that might hint at defense interest. Overture's range of 4,250 miles actually covers a bunch of key routes, but those refueling stops for Pacific flights definitely add some complexity. Still, having travel times could honestly reshape global business and tourism in a big way. The military angle is honestly pretty intriguing. Northrop Grumman's 2022 partnership suggests Overture variants for rapid response missions. Think medevac or reconnaissance at Mach 1.7. This dual-use potential actually mirrors the Concorde's NATO interest back in the 1970s, though, it never really materialized. Boom's ability to serve both airlines and defense could, in theory, offset costs, making supersonic travel viable. The XB-1's success proves the tech works. Now, Overture just has to scale it. Can Boom pull it off? The timeline, certification by 2029, is pretty tight. The Concorde took a decade to develop. Boom's aiming for half that. Regulatory hurdles, fuel costs, and sonic boom restrictions all loom large. Yet the XB-1's flights, investor backing, and production plans really show momentum. If Overture flies passengers by 2030, it'll totally redefine air travel, making London to New York a morning commute. At $5,000 a ticket, it's not cheap, but honestly, it's a bargain next to Concorde's price tag. Will Boom's vision soar, or is 2030 just too ambitious? Drop your take in the comments, especially if you're an aviation buff. Hit like, subscribe, and check our videos on hypersonic tech for more. The skies are calling and Boom's ready to answer.